ఆప్షన్ ఒక్కటి పెడతాము, మిగతాది మన ఇష్టం ఏమైనా పెట్టచ్చు. విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ రామాస్ బ్రదర్ అంటే లక్ష్మణ్ ఒకటి కరెక్ట్ పెట్టేసి మిగతావి జార్జ్ బుష్, జార్జ్ బుష్, మెలిండా ఇవన్నీ పెట్టేసి మనకి ఇంకోటి మనం అటానమస్ కాబట్టి వానికి అసలు ఛాన్స్ ఇవ్వద్దు రాంగ్ పెట్టడానికి, రైటే పెట్టాలి వాడు. ఇవన్నీ సుధాకర్ రెడ్డి సార్ టిక్స్, సుధాకర్ రెడ్డి సార్ చెప్పు. సుధాకర్ రెడ్డి సార్ కంప్లీట్ గా స్టూడెంట్ పక్షపాత అట్లా. మనమేమో ఫస్ట్ లో ఆవేశానికి పోయి బలైపోయినాం కొన్ని రోజులు. మీరు స్ట్రిక్ట్గా ఉండట్లేదు అది అని తిడతాడు, కానీ అక్కడ సినారియో వేరు. యాక్చువల్గా ప్రిన్సిపాల్స్ అట్లనే ఉండాలి సార్, ప్రిన్సిపాల్ కానీ హెచ్ఓడి కానీ అలాగే ఉండాలి. మనం దాన్ని తప్పు అనుకోవద్దు. ఇప్పుడు సర్వైవల్ ఇంపార్టెంట్, అలాగే ఉండాలి. అలా ఉన్నోళ్ళే కరెక్ట్, లేకపోతే ఇప్పుడు సిస్టమ్ రన్ చేయలేరు. పాత కాలంలో హలో ఓకే. So in the last classes we have seen some of the programs. Next program is MFT, MVT and MFT. So MVT stands for memory variable partitioning technology, and MFT stands for fixed partitioning technology. So in the fixed partitioning and variable partitioning there are some differences. So as we have seen in the last classes, if you want to execute any program, పోయాడా సార్? అయ్యో, can anyone please let me know whether you are able to get it? So please try to concentrate. Today's class I am going to explain theory. If possible we will go with the program also if time permits us, otherwise we'll see tomorrow, right? So actually this is there for first mid examination, but it is a part of fourth module. So since we have to cover it for first mid examinations, I am teaching this. With this we are going to stop programs and theory also. I'll be going for recapping the sessions from tomorrow onwards. So these two are the last two programs of first mid examination syllabus, MVT and MFT. So this VT stands for variable technology and FT stands for fixed fixed partitioning. PT for variable partitioning. So what is this partitioning actually? So if you want to execute a program, we know that the program must be executed by the CPU and using different scheduling algorithm. That's what we have seen, different types of scheduling algorithm. When there is only one CPU and there are many number of jobs that are competing to get the CPU, then the operating system is using scheduling algorithms. So based on the scheduling algorithm, the job which is arriving into the ready queue will be given the CPU. So the job which is getting the CPU executes it, and after that the CPU is given submitted to the next job. So we know that in the memory hierarchy, the program should be executed in the CPU, but the program will not be there in the CPU because the program, if the program size is big, the CPU stores the values with the help of registers. And there are only few number of registers. It cannot store all the information in the CPU. So there must be some area where your program should be stored. So we are storing the actual program in the primary memory. Assume that this is primary memory. In the primary memory, values are stored, or program is stored. Program and also data, both are stored in the primary memory. And when the one instruction after the other will be supplied to the CPU, and which is transferred from the primary memory to CPU. We have seen in the very beginning classes. So now we are going to see how, why, what is this memory partitioning and all. Now we know that, assume that right side, you can see there are 4 programs. P1 with 20 units of memory requirement, P2 with 30 units of memory requirements, P3 with 40 units of memory requirement, P4 with 50 units of memory requirement. So we are going with 2 technologies. Now try to concentrate here only. Just I'll remove this and I'll try to come up once again. So assume that this is the memory. Okay, and entire memory is free now. This is the memory, and entire memory is free. So when we are going to execute this program must be executed in the CPU. But CPU cannot hold all the instructions, so we are keeping the program in the RAM. So initially we are assuming that entire memory is free, and when the program comes and when it is ready to execute, this program usually stores it is stored in the secondary storage devices, hard disk or pen drive or any of the secondary storage devices. You can store in the SD card or pen drive or DVD or CD or disk or tape, any of these devices, the program is stored. But during the computer is off, when the computer is off, the values must be stored permanently. And we know that RAM is a volatile memory which cannot hold the values permanently. When the power is off, the values are lost. So we need to retain the program. For that, we are storing the program in the secondary storage devices. So we know that this can be a hard disk, or this can be a pen drive, and this can be a pen drive, or this can be your SD card, or this can be any of the secondary storage devices like tape, or it can be DVD, or it can be CD, or it can be Blu-ray disc. All these are secondary storage devices. So we are storing the program here. And when you want to execute the program, we know that how to open a program or how to run a program. So we have seen, based on the different operating system, different mechanisms are there. So in the DOS operating system, we are invoking the program or running of the program by typing commands. And in the Windows operating system, if you are having a GUI environment, graphical user environment, we are double clicking on the program, or we can run, we can go to the editor and we can run it. So when you are opening a program, so that opening a program means what? When you are clicking on the program is moved from the hard disk to RAM. The program must be moved from the hard disk to RAM, because during the execution of the program must be there in the RAM. And but the program RAM cannot execute the program. It is not a processor. It is only storage element. But where the program is executed in the CPU. Why we are having this many storages? Because CPU will execute the program, and the CPU is a processing unit which is responsible for execution of the program. But CPU cannot hold all the instructions. So that's why we are storing the program in the primary memory. Then why primary memory in between hard disk and RAM? Because the speed differences are more. Hard disk works at the mechanical speed. That may be 3600 revolutions per minute or 700, 200 revolutions per minute. And based on the mechanical devices or motor that is connected to the hard disk, it may work fastly or slowly than 3600 or 700, 200. The general convention used is either 3600 or 700, 200. If the speed motors are there, that may go faster. So, but the CPU is much more faster than this hard disk. So in order to compensate the speed differences between the CPU and memory, so we cannot directly store the value or supply the value from the hard disk to CPU. So that's why this is called secondary storage device. This is not directly connected to the primary storage device. Secondary storage device So from the secondary storage devices, the program or data is moved into the primary storage device. That is called RAM or ROM. RAM and ROM both are primary storage devices only because they are directly connected to the CPU. And in between CPU and RAM, there is another storage called cache memory. So this cache memory is also used to improve the processing speed. It is working based on the principle of locality of preference. So the program which has to be executed or the instruction set of instructions which are to be executed repeatedly will be stored in cache memory, or the program that is to be the instruction that is to be executed for a repeated number of times, or the instruction that is to be executed next can be stored in the cache memory. So we have seen that there are 4 or 3 levels of cache memory based on the computer system. Different levels are there. So in the last classes, when we go to task manager, we have seen how when you are clicking one program, how it is to move from hard disk to RAM to hard disk. So once you are loading the program, once you are opening the program, let's imagine you have a program in your pen drive, and some word file is there. When you are double clicking on that, the particular program is moved from the pen drive to primary memory. So now the program is in the primary memory. Now you can unplug the pen drive. Even then your program will be there in the primary memory. You can see it, you can execute it. As long as the power is there, you will see that program when the power is there. So when there is no power, since the primary memory is a volatile memory, means when it keeps the values as long as the power is there. When the power is off, the values will be lost. So you cannot have that program. I hope you got it. So keep a program in your pen drive, just open it, then you can unplug the pen drive. Your program will be there in the primary memory. You can see it, you can execute, and if you want to save it into the local disk, it can be saved also. So what is our requirement? Why we are going for MVT and MFT? Memory must be partitioned. Why partitioning? Because when a program is a passive entity, active entities is process. The executing status of a program is called process. Running status of a program is called process. So if you want to run the program must be moved from the hard disk to primary memory, and from there it must be supplied to the CPU, and in between that there is a cache memory also. So some of the instructions are kept in cache memory in order to compensate the speed differences between RAM and CPU, or in order to improve the utilization of the CPU, because CPU works very fastly, and that much speed the hard disk directly cannot supply the values to CPU, or the RAM also directly cannot supply the values to CPU, because CPU is very fastest element in the computer system and the fastest unit and fastest storage device. But RAM is little bit less speed than the CPU. So in order to compensate these speed differences, we are using cache memory in between them. Now we are talking about MVT and MFT, variable partitioning technology of the memory, fixed partitioning technology of the memory. So what is this variable? First we'll go with variable partitioning technology. Initially, entire memory is assumed to be a whole. Whole means free space in the memory. So the entire memory is assumed to be free space. And when you want to execute P1 program, and assume that, listen carefully, there are 4 programs, P1, P2, P3, P4 are the programs. So these programs must be executed in the CPU. And when you want to execute them in the CPU, this program must be loaded into primary memory. So that now entire memory, assuming as a single whole or single space, then when you are going, and it will be partitioned when the program is loaded into the primary memory based on the partitioning technology that operating system is using. So what is the technology? That may be MVT or MFT. So in case of MVT, variable partitioning, so what it is doing is, first it is assuming that the entire free space has one whole, and this first program is loaded into the primary memory. So how much memory that is needed into that primary memory, that much will be allotted to the P1 process. So let's imagine each cell is taking 10 units of time, 10 units of memory. Each cell is taking 10 units of memory. And now say this first location takes 10 units, and next location 20, next location 30, next location 40. Thus, ఇది మన హెచ్ఓడి మెయిల్ ఉంది చూడు, అదే మన సిఎస్సి దాంట్లో. నువ్వు భలే ఉన్నావు, ఎందుకు డిలీట్ చేస్తావు? అదేమన్నా నీ లవర్ మెసేజా, మీ ఆడేమన్నా చూస్తుందా? ఉంచుకోవచ్చు కదా. మీ మేడం కూడా లేదు, ఏ మెసేజ్ ఉంచుకున్నా ఏం కాదు ఇప్పుడు నీకు. క్లాస్లో కూడా అదే ఎగ్జాంపుల్ ఇస్తా, బాగా అర్థం కావాలా వాళ్ళకి. సో P1 needs 20 units of memory. So this has to be loaded into the primary memory. So let's assume each cell is taking 10 units of memory. So if you want to load P1, it requires 10 units. So this entire memory, in the entire memory, first two locations are used for P1. First two locations are used for P1. So first P1 needs 10 units of memory. So 10, next 10, 20, up to 20, P1 is occupying. So first partitioning is made. This entire memory, first partitioning. Now we have two partitioning. What are the two partitioning? P1 first partition, 1 to up to this. This is one partitioning, and rest of the memory is another partitioning. Now when you want to load P2, P2 requires 30. So this 30 will be loaded from the 20th location onwards. So if you are adding 30 to this 20 location, you will be getting 30, 40, 50. Up to 50, again you have one more partitioning. What is that partitioning? Second partitioning. So now the entire memory is divided into three parts. What are they? First part is for P1, second part is for P2, and the rest of the parts are assumed to be one part, right? So now first 50 location, one part, and rest of the entire memory as another part. How we are allocating this? First we are assuming that entire memory is 1 unit, and for P1 it requires 20 units of memory space. So we allotted 20 units of this. P2 it requires 30 units, so 30 units is allotted here. And P3, when P3 comes for execution, P3 requires 40. So it starts from 50. It starts from 50. Can anyone please respond? చెప్పి దాదాపుగా పావు గంట 20 నిమిషాలు అవుతుంది. వింటున్నారు లేదో ఒకటైనా చెప్పండి. 50 నుంచి స్టార్ట్ అయితే P3 ఎక్కడి వరకు ఉంటుంది మెమరీ? ప్లీజ్ రెస్పాండ్, అట్లీస్ట్ వన్ ఆఫ్ యూ. If P3 is loaded from 51 onwards, what is the end location of P3? If you are listening, please respond. వింటున్నారా? ఒక్కరైనా వింటున్నారా? హలో, P3ని మెమరీలోకి స్టోర్ చేయాలంటే P3 15 దగ్గర నుంచి స్టార్ట్ అవుతుంది. దీనికి 40 కావాలి. ఎక్కడి వరకు వెళ్తుంది టోటల్ మెమరీ? ప్లీజ్ రెస్పాండ్. Can you please respond? Any one of you? Anyone is there online at least? Please respond. Hello. Hello. CRs, at least CRs, please respond. CRs. నీ సైట్ అమ్మి ఓ కాలేజ్ పెట్టు. హలో, శ్రీనివాస్ సార్ లాగా పెట్టబ్బా. మల్లారెడ్డి సార్ కూడా పెట్టినప్పుడు లక్షల కోట్లు లేవు, చిన్న స్కూల్ కు పాలమ్మే కొన్నాడు, సెంట్ మార్టిన్ స్కూల్. So this is a way how partitioning is done. So for P1, 20 units of memory locations are allotted. P2, 30 units of memory is allotted. P3, 40 units. P4, 50 units is allotted. So we have different memory locations here. For P1, 20, P2, 30, P3, 40, P4, 50. and this type of partitioning is called variable partitioning. So I hope you got it. అర్థమైందా లేదా చెప్పండి, అర్థం కాదంటే మళ్ళీ ఒకసారి చెప్తా. పిల్లలు ఏందబ్బా అటు సైడ్ ఆన్లో ఉన్నారా లేదో లేదు తెలియదు. 40 మెంబర్స్ క్లాస్లో ఉన్నారు, 35 ఒక్కడు కూడా ఆన్సర్ చేయండి, కనీసం వింటున్నారు లేదు తెలియట్లా. హలో So now let us go to fixed partitioning. Fixed partitioning, unlike here we are allotting 20 units of memory for first unit, 30 units per second, 40 for third, 50 for fourth partitioning. We are not doing like this. Here the memory is fixed. So let's assume that we are giving 30 units for every process. So if the process is 30 or less than 30, then that partitioning can be allotted. If the program size is more than 30, in case of fixed partitioning, that program will not be allotted and that will not be executed, right? So P1 needs only 20 units of time. So, but here we have 30 units, so P1 can be allotted, and there is 10 unit of free space is there. That unit of this 10 units of free space will not be allotted to any other program. So this is wasted. This wastage of memory is called fragmentation. And P2 is coming with 30 units of memory requirement. So first program it is already fixed up to 30 for first program, up to 30 for the first program, and then 31 to 40 for the second program. So we'll have up to 40 here, up to 50, up to 60. So this partitioning, if the partitioning is as big as a program size, then this program can be loaded into this partition. But if the program size is bigger than this, the program cannot be loaded and that particular program cannot be executed in case of fixed partitioning, and that memory is wasted. That here the program is loaded, but there is a free space. That space is wasted. And in this case, if you are considering P3 requires 30, so it is loaded from 40, 50, 60, but 20 to 30 free space is wasted. Why? Because it is a partitioning, that space cannot be used for any other purpose. But later we will try to recover the fragmentation. We will try to recover this fragmentation by using defragmentation techniques. So this wastage of memory, where I'm showing red color, is called fragmentation. And here there is no fragmentation because P2 requires 30 units of memory, and P2 is allotted from 40 to 60. Up to this P2 is allotted because P2 needs 30 units of memory. P2 is allotted from 30 to 60. So there is no wastage of memory in in segment 2 or in this partition. And when you want to load this P4 requires 40 units of time, 40 units of memory, but here the whole space is, our free space size is only 30, and we cannot increase it and we cannot accommodate it. So this P3 will never get a chance to execute, and that cannot be loaded into this primary memory if we are using MFT, fixed partitioning technology. And P4 also needs 50 units of time. So P4 also cannot be allotted because the whole size is 30, but the program size is 50. This program cannot be fitted into this hole. So that's why P2, P3 and P4 cannot be executed by this method, because P3 memory size is 40, but the whole size is 30. This P3 cannot be loaded into this free space, so this program cannot be executed. So that's why we are going for variable partitioning. But here also memory wastage is there. If we are going with this, still memory wastage is there, then we are going for another algorithm that we'll see in the fourth module. Actually, this is also part of fourth module only, but this program is there in the first mid syllabus. That's why I'm teaching you theory now. And when you go there, once again we'll be discussing about MBT and MFT. So MBT, MFT completed. If you have any doubt, you can ask me. Yes, sir. Any doubt? Any doubt? అయిపోయిందా సార్ స్వామిదాస్ ఇది మొత్తం కలెక్షన్?